In recent weeks, NASA has stirred widespread scientific curiosity and public fascination by releasing the most detailed and highest-resolution images ever captured of the interstellar comet 3I/Atlas. These remarkable images were recorded by the Mars Reconnaissance Orbiter during the comet's unusually close pass by Mars in early October. The release had been delayed for several weeks, fueling speculation online, and when the data finally emerged on November 19th, the scientific community immediately reignited a series of debates, some grounded in astrophysics, others venturing into more unconventional territory. At the center of the renewed controversy is Harvard physicist Avi Loeb, a figure well known for challenging traditional interpretations and proposing bold hypotheses about extraterrestrial technology. Loeb pointed to unusual jet and plume behaviors visible in the new images, suggesting that the comet's emissions may not align with standard natural explanations. NASA, however, firmly rejected these claims, emphasizing that all current evidence still places 3I/Atlas squarely within the category of natural celestial objects, despite its interstellar origins. The newly released images, particularly those taken by the high-resolution high-rise camera aboard the Mars Reconnaissance Orbiter, show 3I/Atlas as it passed by the red planet, offering the closest and most detailed view humanity has had of an interstellar comet to date. This alone makes the event scientifically significant, as studying objects that originate from outside our solar system can help researchers better understand the composition, behavior, and formation processes of distant planetary systems. Yet Loeb's persistent assertion that 3I/Atlas might be an artificial object or spacecraft has drawn substantial attention. His claims center on the trajectory and shape of the comet's plumes, jets of gas and dust expelled as the object heats up when approaching a star. According to Loeb's analysis, the jets observed do not follow the expected behavior typically seen in comets. Instead of pointing away from the sun, as would be expected given the influence of solar heating and solar radiation pressure, some plumes appear to align in the direction of the comet's travel. In a detailed post he published on Medium, Loeb expanded on this point, explaining how scientists generally interpret cometary jets. When sunlight heats pockets of ice on the comet's surface, those regions release gas and dust, forming plumes that naturally extend in the direction opposite the sun. In other scenarios, solar wind, a continuous flow of charged particles from the sun, can push debris outward, affecting the direction of the jets. Loeb stated that it is easy to explain plumes oriented toward the sun or away from it, as these are normal behaviors governed by solar illumination or interactions with radiation pressure. Additionally, a stream trailing behind a comet can also be accounted for, since solar wind can slow down ejected particles relative to the comet, creating a tail that drifts behind the moving object. However, Loeb argued that the situation becomes far more intriguing when a plume does not follow any of these natural orientations. In the case of 3I/Atlas, one of the emissions appears to extend perpendicular to the direction of the sun and even ahead of the object itself. This orientation is unusual, he suggested, and not easily explained through conventional cometary physics. He then proposed a speculative yet attention-grabbing idea. Could the plume be a technological signature, some form of propulsion, illumination system, or even a defensive countermeasure designed to clear micrometeorites from the object trajectory? Loeb emphasized that micrometeorites pose significant hazards to spacecraft moving through interstellar space, and an advanced civilization might engineer systems to mitigate that risk. To him, the anomalous plume pattern seen in the images could represent evidence of such an engineered mechanism. NASA, however, responded swiftly and unambiguously. During a live-stream presentation accompanying the image release, NASA Associate Administrator Amit Kshatriya addressed the circulating claims directly. He reaffirmed that there is no credible evidence to support the idea that 3I/Atlas is a spacecraft or artificial object. According to Kshatriya, the comet behaves exactly like other comets observed throughout human history, aside from the fact that it originated from beyond our solar system. He emphasized that while interstellar objects are rare and scientifically valuable, rarity does not automatically imply non-natural origins. This object is a comet, Kshatriya stated plainly. It looks and behaves like a comet, and all evidence points towards it being a comet. But this one came from outside the solar system, which makes it fascinating, exciting, and scientifically very important. NASA is currently conducting an extensive observational campaign, bringing together data from multiple spacecraft and telescopes positioned throughout the solar system. The agency is observing 3I/Atlas through 12 different lenses and scientific instruments. The Mars Reconnaissance Orbiter is providing high-resolution optical imagery, while the MAVEN spacecraft is capturing ultraviolet data, allowing scientists to analyze the comet's chemical composition, particularly the types of gases released as it approaches the Sun. Meanwhile, instruments designed to monitor solar activity, such as NASA's Solar Terrestrial Relations Observatory STEREO, are also capturing data on how solar radiation and solar wind interact with the comet. Other spacecraft, including the Psyche mission and the Lucy mission, both primarily designed to observe asteroids, have turned their cameras toward 3I/Atlas to contribute additional observational angles and wavelengths. Each of these instruments offers a unique window into the comet structure, behavior, and composition. Together, they help scientists build a comprehensive understanding of how interstellar objects differ from the comets and asteroids native to our solar system. The observations will allow researchers to study whether 3I/Atlas contains unusual isotopes, uncommon chemical elements, or unexpected structural patterns that might hint at the history of its original stellar system. Interstellar comets are extremely rare, with only 2 confirmed before 3I/Atlas, namely 1I/Oumuamua and 2I/Borisov. Both generated massive scientific debate, with Oumuamua in particular becoming famous for its unusual shape, lack of a visible tail, and unexpected acceleration. Those anomalies led Loeb to propose that Oumuamua might also be an artificial object, a theory that remains controversial among astronomers and largely unsupported by mainstream scientific consensus. The case of 3I/Atlas is unfolding in a similar way, though NASA is taking a proactive approach by collecting as much data as possible during the comet's passage. Understanding interstellar objects is crucial for a deeper grasp of cosmic evolution. Every solar system forms under different conditions, with varying chemical environments and gravitational influences. When an object is ejected from such a system and eventually drifts into ours, it carries with it precious information, a time capsule from a distant stellar nursery. These comets can reveal clues about planetary formation, the distribution of organic molecules, and the prevalence of certain materials in other star systems. Despite NASA's firm dismissal of extraterrestrial technology theories, Loeb's comments have kept the public conversation lively. Many supporters argue that scientific progress often begins with unconventional questions, while critics contend that his claims risk misrepresenting data and overshadowing legitimate scientific inquiry. Regardless of one's stance, the exchange underscores a broader public fascination with the possibility of extraterrestrial life and the unknown mysteries of interstellar space. The scientific method thrives on data, and NASA's ongoing observation campaign will supply an abundance of it, giving researchers years of material to analyze. For now, 3I/Atlas continues its journey through the solar system, gradually receding from Mars and moving deeper into the inner regions. As more data is processed and released, scientists hope to refine their understanding of how interstellar comets behave, how they compare to our local cometary population, and what secrets they may reveal about the vast cosmic environments beyond our Sun. Whether the plume anomalies noted by Loeb will eventually be explained through standard physics or remain unresolved curiosities, the comet's arrival offers a rare opportunity for discovery. Its passage is a reminder of how dynamic the universe is and how objects from unimaginable distances can occasionally wander into our neighborhood, challenging us to observe, question, and explore with both rigor and imagination.